This video demonstrates the data preparation phase for data modeling. The topics to be covered are how to partition the data in Python, how to balance the training data set in Python, and how to build random forests in Python. Let's begin. How to partition the data in Python. Scikit-learn alias sklearn is the most powerful and robust library for machine learning in Python. The scikit-learn library provides us the model selection module, which we have the splitter function train, test, split. The syntax is as follows. Now we will discuss each of the parameters one by one. The parameters are first arrays. Arrays contains inputs such as list, arrays, data frames or matrices. The second parameter is test size. Test size is a float value whose value ranges between 0.0 and 1.0. It represents the proportion of our test size. The third parameter is train size. This is a float value whose value ranges between 0.0 and 1.0. It represents the proportion of our train size. Fourth parameter is random state. It is used to control the shuffling applied data before applying the split. The fourth parameter is shuffle. This parameter is used to shuffle the data before splitting. Its default value is true. And the last parameter is stratify. This parameter is used to split the data in a stratified fashion. How to balance the training data set using Python. An imbalanced data set can be defined as a classification predictive modeling problem where the distribution of examples across the classes is not equal. That is, the class distribution is not equal or close to equal and is instead biased or skewed. The problem is predominant in scenarios where anomaly detection is crucial, like identification of rare diseases like cancer, tumor, etc., fraudulent transactions in banks. Now, how can we fix a data set that is imbalanced? The techniques that can be used for fixing the data set imbalance are: first is resampling the data set. Here, we focus on balancing the classes in the training data preprocessing, before providing the data as input to the machine learning algorithm. The main objective of balancing classes is to either increase the frequency of the minority class or decrease the frequency of majority class. There are two approaches for balancing the data set. These are undersampling and oversampling. The second method is using k-fold cross-validation. The cross-validation should be applied properly while using the oversampling method to address imbalance problems. If cross-validation is applied after oversampling, basically what we are doing is overfitting our model to a specific artificial bootstrapping result. That is why cross-validation should always be done before oversampling the data, just as how feature selection should be implemented. And the last method is clustering the majority class. Instead of relying on random samples to cover the variety of training samples, clustering the abundant class in R groups, with R being the number of cases in R, is effective. For each group, only the midioid is center of cluster, so only the midioid is kept. The model is then trained with the rare class and the midioid only. Next is random forest. Random forest is a commonly used machine learning algorithm trademarked by Leo Bremen and Adele Cutler, which combines the output of multiple decision trees to reach a single result. Its ease of use and flexibility have fueled its adoption as it handles both classification and regression problems. This is what a random forest looks like. Let's see an example. In this example, we will learn how to build a random forest in Python. First, we will need some data. To use a realistic example, I have retrieved the weather data source for Seattle. Next, the following Python code loads the CSV data and displays the structure of that data. This is what the data looks like. Now, I will explain each of the column one by one. The year column is of the year 2016 for all data points. Month contains the number of month of the year. Day is the number of day of the year. Week contains day of the week as a character string. Temp 2, max temperature 2 days prior. Temp 1, max temperature 1 day prior. Average, historical average max temperature. Actual, max temperature measurement. Next is friend, forecast account and forecast under. This is friend. Friend is your friend's prediction of random number between 20 below the average and 20 above the average. Next, we will identify anomalies as well as missing data. If we look at the dimensions of the data, we notice that there are only 348 rows. And we know that there are only 348 rows, but we have 366 days in an year. Therefore, missing data can impact an analysis as can the correct data or outliers. In this case, the missing data will not have a large effect and the data quality is good because of the source. We can see there are 9 columns which represent 8 features and 1 target actual. To identify anomaly, we can quickly compute the summary statistics. Here I have computed the statistics. There are not any data points that immediately appear as anomalous or no zeros in any case of measurement columns. Next, we will go for the data preparation. Because we are sure the point where you can just feed the raw data into a model and have it return an answer. We will need to do some minor modification to put our data into machine understandable terms. We will use pandas for our data manipulation. Next, we will do one-hot encoding. The first step for us is one-hot encoding. This process takes categorical values such as days of the week and converts it into numerical representation without an arbitrary ordering. Days of the week are intuitive to us because we use them all the time. We will hopefully never find anyone who doesn't know what MON refers to the first day of work week, but machines do not have any intuitive knowledge. What computers know is numbers, and for machine learning we must accommodate them. We could simply map days of the week to numbers 1 to 7, but this might lead to the algorithm placing more importance on Sunday because it has a higher numerical value. Instead, we change the single column of weekdays into 7 columns of binary data. This is best illustrated pictorially. One-hot encoding takes this week, Monday, Tuesday, Wednesday, Thursday and Friday and turns it into zeros and ones. This is what it looks like after hot encoding. We will also convert the pandas data frame to NumPy arrays because that is the way this algorithm will work. I will save the column headers, which are the names of the features, to a list for use for later visualization of data. Next is training and testing the sets. This is one final step of data preparation, splitting data into training and testing sets. During training, we let the model see the answers, in this case the actual temperature, so it can know how to predict the temperature from features. We expect there to be some relationship between all the features. Next, we will establish the baseline. Now we will train our model and make predictions on the test set. Then we will determine the performance matrix. And we can also improve the model if necessary. Now we can take a look at the graph which we have plotted. This is what it looks like. We can also create a reduced size of this image with labels.